Safir, the dream team in entrance coaching.
So, a very good day to all of you. Welcome to Rise Up section. Today's topic is rotational motion, system of particles and rotational motion. So, we'll be briefly discussing about some of the important questions related to rotational motion and system of particles. So, we classify the chapter into different sections. Like first, we'll discuss some questions based on important questions based on center of mass. Then we'll discuss some important questions based on moment of inertia, and then we discuss about the rotational dynamics terms like omega, torque, angular momentum, alpha, all that things. Yeah. So we have selected the most important questions, and that can come for the upcoming NEET exam. Yeah. So just let me introduce this first. So here, when we talk about a system of particles, the concept of system of particles arises when we want to deal a group of particles as a point object, a very big size of object as a single point object. When we deal with a system of particles, we consider the concept of a point object. So clear. So we first will discuss about center of mass. Center of mass. So what is the concept of center of mass? When we consider a system of particles, consider a lot of particles masses distributed in a region, in a given region, and we need to find out the point where the entire mass is assumed to be concentrated. We use the concept of center of mass. That the definition of center of mass is that the point at which the entire mass is assumed to be concentrated, that is known as center of mass. The point at which the entire mass is assumed to be concentrated is known as the center of mass. So how to calculate the position of center of mass? When we consider a coordinate system like this, suppose let me introduce with the first single dimension coordinate. That is, let us consider only the x-axis in which the masses are distributed. Let us consider mass m1 and the mass m2, and we consider a point from which the masses has to be, the distance to the masses has to be calculated. We take the point from the origin, that is the reference point we consider. Here it is x1 to the mass m1, and then x2 to the mass m2. So the distance m1 is distance for m1 from the origin is x1, distance for m2 from the origin is x2. So how to calculate uh, the position of center of mass in this? So we use the equation xcm equal to m1 x1 plus m2 x2 divided by m1 plus m2. I have considered only two masses. The center of mass is calculated by using the equation m1 x1 plus m2 x2 divided by m1 plus m2. Here m into x, that is mass into distance to that mass from the origin, is known as the moment of mass. It is known as a moment of mass. That is, if we have n number of masses distributed, then xcm can be written as sigma I is equal to 1 to n mi xi divided by sigma I is equal to 1 to n mi. So, this is the equation to calculate center of mass. I have considered only the x coordinate. So, center of mass in this case is lying between m1 and m2, not exactly at the midpoint. If m1 and m2 is of the same value, if m1 and m2 is of the same value, then xcm can be calculated by using the equation mx1 plus mx2 divided by 2m. That is, xcm is equal to m1 x1 plus x2 by 2. x1 plus x2 divided by 2. Right, xcm is equal to m1 x1 plus x2 by 2. That is, for any symmetrically distributed masses, for any symmetric distributed distribution of masses, the center of mass will be exactly at the geometric center. So, in this case, initially I have taken m1 and m2 are different masses. The second case I have considered m1 and m2 are of identical mass. They are identical masses. In that case, we got the equation xcm equal to x1 plus x2 by 2. That means it is exactly at the center of m1 and m2. And you can see that the center of mass may not lie on the mass. Center of mass may not lie on the mass. It can be outside the mass, in between the masses. It will be lying closer to the greater mass. If it is identical, exactly geometric center. If one mass is more than the other mass, the center of mass will be nearer to the greater mass. Yeah. So, in general, when we discuss about x, y, z coordinate, we deal with the letter r, that is a position vector which comprises xcm, which includes xcm, ycm and zcm. So, we use the equation rcm equal to m sigma I equal to 1 to n mi Ri divided by sigma I equal to 1 to n mi. So, this is the equation to calculate the position of center of mass. If we have all the three coordinates, that is x, y and z. So, separately we will calculate xcm, ycm and zcm, that is given in the question. We will do that as an example afterwards. So, xcm, ycm and zcm, and we got the answer by using the coordinates x, y and z. Is it clear? Okay. Now, when we discuss about the principle of moments, what is moment of mass? Mass into distance is moment of mass. So, principle of moment, we will discuss what is principle of moment. We will consider two masses, let that be m1 and other be m2, m1 and m2. And we consider a point, we know how to calculate the center of mass. We consider an origin in such a way that the distance of mass m1 from the origin, let it be r1, let this be the origin r1, distance to m2, it is r2. So, in order to calculate the center of mass position RCM will be equal to m1 r1 plus m2 r2 divided by m1 plus m2. This is what we have discussed already. Now, if we are considering the center of mass itself, the position of center of mass itself to be the origin, then RCM will be equal to 0. If we consider the position of center of mass itself to be the origin, then we consider RCM is equal to 0. Therefore, 0 equal to m1 r1 plus m2 r2. 0 equal to m1 r1 plus m2 r2. That is, m1 r1 is equal to minus m2 r2. m1 r1 is equal to minus m2 r2. That is m1 by m2. What is this negative sign indicating? Negative sign shows that the center of mass is, the masses are distributed on both the sides of center of mass. It will be distributed about the center of mass on both the sides. So, that is m1 by m2 is equal to minus of r2 by r1. So, r2 by r1. So, when we use this equation in numericals, we do not have to consider this negative sign, because negative sign only indicates the distribution of masses on both the sides of center of mass. Is it clear? Mass are distributed on both the sides of center of mass. So it's very important to know how to calculate. There's a shortcut equation to calculate the position of center of mass from any one mass. There's a shortcut equation to calculate the position of center of mass from any one mass. For that, we consider m1 and m2 separated by distance. We'll let it be d, like this, separated by distance d, and we consider, let it be, position of center of mass is, so here m1 and m2. M1 is assumed to be more than M2. If M1 is assumed to be more than M2, M1 by M2, it is greater than 1, correct? M1 by M2 is greater than 1. That shows that R2 by R1 is greater than 1. If M1 by M2 is greater than 1, then R2 by R1 is greater than 1. That shows that the center of mass will be more nearer to the greater mass. R2, suppose I am taking this is the position of center of mass, then this is R1. This is R1. After discussing the principle of moments, we consider the center of mass in between M1 and M2, and this is R1, this is R2. So greater is the mass, center of mass will be more nearer to the greater mass. That is this concept, this equation indicates. Greater is the mass, center of mass will be more nearer to the greater mass. So we consider center of mass is more nearer to M1. Therefore, if we need to calculate what is R1, we have a shortcut equation, that is M1 by M2 equal to R1, that is R2 can be written as D minus R1 divided by R1. Alright, R2 can be written as D minus R1 divided by R1. So M1 by M2 is equal to D minus R1 by R1. That shows that R1 equal to M2 into D divided by M1 plus M2. This is a shortcut equation to calculate the position of center of mass from M1. R1 is the position of center of mass from M1. This is a shortcut equation to calculate the position of center of mass from M1. Suppose you need to find out the position of center of mass from M2. You need to find out what is the position of center of mass from M2. Then we use the equation R2 equal to M1 divided by M1 plus M2 into D. Clear? M1 divided by M1 plus M2 into D. So these equations can be used to calculate the position of center of mass very easily. You can solve the questions in the stipulated time. Okay. So let us have an example for this. You can see question number 1. So if we need to write, you can note it down. I'll wait. Okay. Now, if I finish writing, we'll see the first question. Question number 1. The center of mass of the system has a position vector R1 equal to. So we have two masses. M1 and this is M2. Position vector R1 is equal to I plus 2j plus k, and R2 it is equal to minus 3i minus 2j plus k, minus 3i minus 2j plus k plus k. M1 it is given as 1 kilogram. M2 it is given taken as 3 kilogram. So how to find out the position of center of mass? So we use the equation RCM is equal to M1 R1 plus M2 R2 divided by M1 plus M2. Alright, M1 R1 plus M2 R2 divided by M1 plus M2. M1 R1 plus M2 R2. So substitute that. 1 into R1, I plus 2j plus k plus M2, it is 3. 3 into R2 minus 3i minus 2j plus k divided by M1 plus M2. M1 plus M2 is 1 plus 3. So we'll be getting I plus 2j plus k minus 9i minus 6j plus 3k divided by 4. So we'll be getting I minus 9I can be taken as so that is RCM equal to I minus 9I minus 8I, then 2J minus 6J minus 4J minus 9 plus K plus 3K, that is plus 4K divided by 4. So we'll be getting RCM is equal to minus 2I minus J plus K. So the position of center of mass in the vector form, it is equal to minus 2I minus J plus K. Hope you understood, right? Okay. Now we'll see the next question. We'll move on to the next one. Everyone finished writing? Okay, next one. We'll see the next question. So this question can be solved by using our shortcut equation we discussed previously. So you can see the question. The center of mass of the system from the 5 kilogram particle is nearly at a distance of. So we have 5 kilogram, and we have 10 kilogram separated by distance of 1 meter. Separated by distance of 1 meter. And the center of mass of the system from the 5 kilogram particle is nearly at a distance of. So 5 kilogram, they have asked to find out the position of center of mass from 5 kilogram. So in the previous section, we have discussed that how to find out the position of center of mass from a given mass. So here, the center of mass will be more nearer to which mass? The center of mass will be more nearer to the 10 kilogram mass. So the value we are going to get will be more than 0.5. The first interpretation, that is 50 centimeter it will be more than 50 centimeters. So we can eliminate these two parts. These two options can be eliminated. That is because it will not be exactly at the 50 centimeter. It will not be less than 50, but it will be more than 50 centimeter. So either 67 centimeter or 80 centimeter. We will discuss that. So what is the equation? Let this be the position R1. So R1 equal to M2, the other mass. Considering the distance from 5 kilogram. So we need to use 10 kilogram on the numerator divided by 5 plus 10 into separation between the two masses, 1 meter. So R1 is equal to 10 divided by 15, that is 52, 53, 0.67 meters. See this? Very easy, right? It will not take more than 1 minute, or it will be taking only 30 seconds to solve these questions if you know this equation. Hope you understood, right? Okay, good. Krishna, 67 centimeter, you got the answer, 67 centimeter, good. Abhinav, Simon, I hope you have got the answer. Good. Okay, so we shall move on to the next question, question number 3. So there is another type of question where the mass will not be given in the question, they will be giving only the dimensions. From that, either we need to predict what is the mass, or we need to find out what term can be an alternative to the given mass. So in this question, It's a very typical question that can be asked for the exam, because the student will be confused where is the mass given in this. He will be confused how to use this, where is the mass given. Unless we know the mass, how can we calculate the center of mass position? He will be confused. So this question can be asked for the exam very typically. The question goes like this: the coordinates of the center of mass of the system of uniform road are. So we have two uniform road. We have two uniform road like this. A road, a sleeping road, that is a horizontal road, is having a length L. The vertical road is having a length of 2L. Uniform road means the mass distribution will be same. And if we consider the mass M for this, mass M for the road of length L, then we need to consider mass 2M for the road of length 2L. Understood? It will be double the mass. So it is mass will be M. If it is M for L, then it will be 2M for 2L. So we'll find out what is the position of center of mass. You can see they have plotted the center of mass both along the x-axis and along the y-axis. So we need to find what is xcm first. We'll draw the coordinate system like this: x-axis and this is y-axis. About the x-axis, since it's a uniform road, it will be exactly at the geometric center. It will be exactly at the geometric center. In the first case, it will be exactly at a distance, that is x equal to L by 2, equal to L by 2. Y coordinate for that will be equal to 0. Understood? This is x1, y1. Now in the second mass, we have 2m as the mass. This is m. Second mass is 2m, exactly at the geometric center of the road of length 2L. And for that, the coordinate x2 will be equal to 0. Y2, it is equal to L, because the total length of the second road is 2L. So half of that will be equal to L. So now we'll use the equation for xcm and ycm separately. xcm is equal to m into m1 x1 plus m2 x2 divided by m1 plus m2. There should not be any confusion in this, because when we substitute m1 x1 plus m2 x2 divided by m1 plus m2 should be the equation, and m1 it is equal to, we'll take it as m, x1 value is L by 2, m2 it is equal to 2m, and x2 value for that is equal to 0, and divided by m1 plus m2, m plus 2m. So when we solve this, we'll get the equation as, we'll get the value as m is getting cancelled, L by 2 by 3, so we'll be getting L by 6. Solving it, we'll be getting the values L by 6. So xcm equal to L by 6. Is it clear? Similarly, we can find the value for ycm. Ycm is m1 y1 plus m2 y2 divided by m1 plus m2. m1 y1 plus m2 y2 divided by m1 plus m2. So ycm is equal to m1 y1, m into y1 value, you can know that it is equal to 0, plus m2 it is 2m, y2 it is equal to L divided by 3m. So ycm is equal to 2L by 3, is equal to 2L by 3. So the answer lies as option B. So option C, and this is L by 6 and L by 6 and 2L by 3. Understood? Yes, Abhinav will repeat it once again. See that. So we have two uniform roads like this. In the first road, we have a length L and the mass is m. Second road is having a length of 2L and mass is 2m. Length L, if it is having a mass m, the length 2L will have a mass of 2m. That is uniform road means when the length is doubled, the mass will be doubled. So that is how we have constructed this uniform roads as a point mass in a coordinate system like this. We have taken x-axis and y-axis and we have taken M as a point object for the road, a point mass for the road of length L at a distance of x1 equal to L by 2, because this mass is assumed to be concentrated completely at its geometric center. So we consider it will be L by 2. And the second case, x2 equal to, second case, the mass is at the geometric center of the second road. So it is at x2 equal to 0, y2 will be equal to L. Understood up to that? Okay, now we apply the equation XCM and YCM. XCM and YCM, that directly we use the equation M1 x1 plus M2 x2 divided by M1 plus M2. So that is why XCM and YCM we have introduced like the equation directly, and then we substitute coordinates x1 and x2. So that the remaining is simplification, right? Okay. Next we'll discuss the fourth question. See the fourth question. Three identical spheres, each of mass 1 kilogram, are kept as shown in the figure, touching each other with their centers on a straight line. If the centers are marked P, Q, R respectively, the distance of center of mass of the system from P will be equal to. So we have been provided with three identical spheres, 1, 2, and 3. One P, second one is Q, third one is R. Right. So the position center of mass will consider the spheres to be distributed as a point mass like this. Here it is M. This M. Second at the point Q, another mass M. Third at this point, another mass M. So all the three masses are identical, and it is located at P, Q, and R respectively. So it is only along the x-axis. So we just need to consider only the x coordinates. So XCM is equal to M into 0, because the first mass is at the geometric center itself. The first mass is at the geometric center itself. So it is M at the origin itself. So M into 0 plus second mass, it is at a distance of PQ from the origin, and third mass, it is a distance of PR from the origin divided by total mass M plus M plus M. So XCM is equal to PQ plus PR divided by 3. PQ plus PR divided by 3. Is it clear? Okay. Now we shall move into the fifth question. Now this is another typical question where the mass is not given. It's an irregular shaped body. For an irregular shaped body, how to consider the mass and how to relate mass with other terms like area, volume, and density. So if mass is not given, then we can replace mass with area like this. Mass is equal to volume into density. Mass is equal to, we'll take mass is equal to volume into density. Mass is equal to volume into density. Volume will take area into thickness into density. So mass is directly proportional to area provided thickness and density are the same. Directly proportional to area provided thickness and density are same. Clear? So we'll apply that here. Find the center of mass of uniform L-shaped lamina. Uniform L-shaped lamina. Listen. So figure given. So in this figure, we will consider these masses, this irregular shaped lamina, this irregular shaped figure into two clear laminas. First one, the lower part, which is having the center of mass exactly at its geometric center. Let this be mass M1. The second mass, the geometric center of that particular lamina, which is at M2, like this. Let that be M2. Now we need to mark the position coordinates for M1 and M2. For M1, we'll consider the distance from origin to that point. Here it is 1 meter. 1 meter, the total length of the lower base is 2 meter. So its geometric center, so x1 will be 1 meter, comma, what will be what is y1 for this? This is 1 meter height, so y1 coordinate will be 0.5 meter, will be 0.5 meter. So x1, y1. So the mass m1 has a coordinate of x1 comma y1. That is m1 has a coordinate of 1 meter comma 0.5 meter. Now we'll take the mass m2. We'll consider the mass m2. M2 is at a position of x2. X2 means it is 1 meter, half of 1 meter, which is equal to 0.5 meter. So 0.5 meter, comma, what will be y-axis? So it is if it is 2 meter, then this will be 1 meter. This is 1 meter. So height will be 1 meter, 1.5 meter, right? Up to this, the height will be 1 meter plus 0.5 is 1.5 meter for M2 in the y coordinate. So M2 is having coordinate of M2 is equal to x coordinate is 0.5 meter, y coordinate is 1.5 meter. This is x2, y2. Understood? So when we simplify this, now we'll consider the coordinates. And we use the equation xcm is equal to m1 x1 plus m2 x2 divided by m1 plus m2 divided by m1 plus m2. That is, instead of m1, we can replace it with a1 into x1 because m is directly proportional to the area. a1 x1 plus a2 x2 divided by a1 plus a2 divided by a1 plus a2. Therefore, xcm equal to a1. What is the area of the first one? Area is length into breadth. 2 into 1, it is 2. x1, it is x1, it is 1 meter. Already we written this 1 meter. Plus what is area a2? a2 is 1 into 1, it is 1. Into what is x2? It is 0.5 meter divided by a1 plus a2, that is 2 plus 1. We'll be getting 2.5 divided by 3. 2.5 divided by 3 or 5 by 6. It is 5 by 6. Our xcm we got it as 5 by 6. Now ycm is equal to m2 m1 y1 plus m2 y2 divided by m1 plus m2. ycm is equal to m1 y1, that is a1 y1 plus A2 y2 divided by A1 plus A2. Simplify this. Well, again A1 value it is again 2, y1 the value it is equal to 0.5, A2 the value it is equal to 1, and y2 value it is equal to 1.5 divided by A1 plus A2, it is 2 plus 1. So again I will be getting 2.5 plus 1.5 divided by 3. So we will be getting 4 by 3. So YCM it is M1 Y1 plus M2 Y2 divided by M1 plus M2. M1 the value it is corresponding to A1. A1 is 2 into 1. 2 into Y1 it is Y1 is 0.5. Y2 it is 1 into 1.5. Area for the second one is 1 into 1.5. Y2 is 1.5 divided by 2 plus 1 3. 2.5 plus 1.5 divided by 3 it is equal to 4 by 3. So the coordinate XCM YCM is equal to XCM comma YCM is equal to 5 by 6 comma 4 by 3. 5 by 6 comma 4 by 3. So you have to correct the last option as 4 by 3. 5 by 6 comma 4 by 3. Is that clear? I'm sorry. Small correction in this. Sorry. 2 into 0.5 is 1 plus 1.5 divided by 3. 2.5 divided by 3, I'm sorry. It is 5 by 6 itself. Answer is 5 by 6, option D. Sorry, this is a small correction. I've just I mistook the value as 2 plus 0.05. So it is 2 into 0.5 is 2.1 1 plus 1.5 divided by 3. 2.5 divided by 3 is 5 by 6. Correct. So it's a careless mistake. Understood how the mistakes are coming in this. So it's a careless mistake. So sorry for that. So we'll be getting 2 into 0.5, it is 1 plus 1.5 divided by 3. 2.5 by 3 is 5 by 6 itself. Okay. Okay. So next we shall discuss about the moment of inertia, and then we'll do some examples based on that. Moment of inertia. Moment of inertia. So what is moment of inertia? You know what is inertia, right? The tendency of a body to continue in its state of rest or in uniform motion is known as inertia. Now when we consider rotational motion, the tendency of a body to continue in its state of rotational motion is known as inertia. So moment of inertia is a tensor quantity, and it is given by the equation I equal to mr square for any mass which is moving about an axis of radius axis in a circular path of radius r. So we consider this is a path. This is the axis about which the moment of inertia is calculated for the given mass m. Then this is the radius r. The moment of inertia of this mass about this axis is given by I equal to mr square. I equal to mr square. That is SI unit is kilogram meter square. Kilogram meter square. It's a tensor quantity. The tensor quantity. So when we consider moment of inertia, we need to know what is radius of gyration. Very important term. Radius of gyration. Radius of gyration. Let it be k. Radius of gyration. Let it be k. Suppose we consider a irregular shaped body like this, and we are going to calculate what is the moment of inertia about this axis. And we consider mass m1 which is moving about this axis. of radius r1, we consider another mass m2 which is moving about this axis with the radius r2, another mass m3 is moving about this axis with the radius of r3. It goes like this. So let us consider there are n number of masses. In order to calculate the moment of inertia of the system of this rigid body, we use m1, m2, m3, m4, etc. up to mn, and we have considered the distance of this mass m1, m2, m3, etc. towards the it is a perpendicular distance to the axis of rotation. Here we are considering the perpendicular distance to the axis. Center of mass അങ്ങനെ ഇല്ലായിരുന്നു. Center of mass നമ്മൾ ഒറിജിനിലേക്കാണ് ദൂരം എടുത്തത്. In case of moment of inertia, we consider the mass into the square of the perpendicular distance of the mass to the axis of rotation. So the equation of total moment of inertia is m1 r1 square plus m2 r2 square plus etc. plus mn rn square. Right? This is the equation of moment of inertia for this body about the axis. Let this be the x-axis or y-axis, about the axis y. So instead of calculating like this, if I'm having if all the masses are same, if I'm saying that all the masses are same, if m1 equal to m2 equal to etc. equal to mn equal to m, then I is equal to m into r1 square plus r2 square plus etc. plus rn square, correct? Etc. plus rn square. Now we need to, instead of calculating this moment of inertia like this, we consider the center. We will find out the center of mass for this system, and we assume that the center of mass is at this point, like this. It is at this point. This is the center of mass. So center of mass be at this point. The entire rigid body is replaced by this concept of center of mass, and we consider only a point mass at this point, which is at a distance. Let that be k. That will be k. And we find out the moment of inertia of this mass about this axis, and if we're getting the same value as before when we calculated the moment of inertia for each masses, and then we summed up the same value, if I'm getting here, then I can say that the distance between the center of mass, distance from the center of mass to the axis, is known as the radius of gyration. Known as radius of gyration. നമ്മൾ ഓരോ മാസം ഓരോന്ന് എടുത്തെടുത്ത് ഓരോ മാസം സെപ്പറേറ്റ് എടുത്ത് നമ്മൾ മൊമെന്റ് ഓഫ് ഇനർഷ്യ കണ്ടുപിടിച്ച് ഓരോ മാസത്തിനും മൊമെന്റ് ഓഫ് ഇനർഷ്യ കണ്ടുപിടിച്ച് സം ചെയ്യുന്നതിന് പകരം നമ്മൾ ചെയ്യുന്ന എന്താ, ഈ കംപ്ലീറ്റ് മാസ് റിജിഡ് ബോഡിയിൽ സെൻട്രൽ മാസിന്റെ പൊസിഷൻ കണ്ടുപിടിച്ചു. എന്നിട്ട് ആ പൊസിഷനിൽ നിന്ന് നമ്മൾ ഒരു ഡിസ്റ്റൻസ് മാർക്ക് ചെയ്തു. ആ ഡിസ്റ്റൻസിൽ കിട്ടുന്ന മൊമെന്റ് ഓഫ് ഇനർഷ്യയും നേരത്തെ നമ്മൾ ഓരോന്നും സം ചെയ്ത് ഓരോന്ന് സെപ്പറേറ്റ് എടുത്ത് സം ചെയ്തപ്പോൾ കിട്ടിയ മൊമെന്റ് ഓഫ് ഇനർഷ്യയും സെയിം ആണെങ്കിൽ, ദിസ് k is known as the radius of gyration. That is, I in this case is m into k square. I in this case is m into k square, which is equal to m into r1 square plus r2 square plus etc. plus rn square. See this. This is capital M. This is capital M. This is small m. So n into small m into k square equal to m into r1 square plus r2 square plus etc. plus rn square. That is, k is equal to root of r1 square plus r2 square plus etc. plus rn square divided by number of particles. So this is a general equation to calculate the radius of gyration, and this is also known as root mean square distance. Root mean square distance is also known as root mean square distance. Also known as root mean square distance. Actually, it's a very important term related to center of mass. There is a moment of inertia, that is root mean square distance. So instead of calculating moment of inertia separately for each mass and then we are summing up, we just need to find out where is the center, what is the position, where is the center of mass, and then we find the distance to that axis where we find out the moment of inertia. Then we calculate the value, and then that value, moment of inertia, will be same as before. Then the distance of mass from the axis is known as the radius of gyration. This is also known as root mean square distance. It's clear? Okay. Now we'll find out what is the moment of inertia for this three particle system in this. See, three particles each of mass m are situated at the vertices of equilateral triangle ABC of side L centimeter, and the moment of inertia of the system about a line AX perpendicular to ABS. So we are supposed to find out what is the moment of inertia about the line AX. About the line AX. So what we do is that we will first consider the distance of each perpendicular distance of each mass to the axis. The side length is L. We know that the side length is L, and L. This is L, and this is L. 60 degrees angle. So mass M A, which is at the axis, there is no moment of inertia for this mass A, but B is at a distance of L from this axis, so it is M into L square. Then this distance, it will be, what is this distance? The perpendicular distance of L by 2, correct? It's an equilateral triangle, so it is L by 2. So when you calculate the moment of inertia for this given system, I is equal to M into 0 for the point mass at A, plus m into L square for the mass at B, then m into L by 2 the whole square for the mass at C, divided by total mass, that is 3m, sorry, not by 3m. So m into 0 plus m into L square plus m into L by 2 the whole square. So we'll be getting I is equal to mL square plus mL square by 4 plus mL square by 4, which is equal to 5 by 4 mL square, equal to 5 by 4 mL square. 5 by 4 mL square. Answer is option C. Is it clear? Next one. The ratio of radius of gyration of circular disc to that of a circular ring, each of same mass and radius around the respective radius. The ratio of radius of gyration of circular disc to that of circular ring, each of mass m, same mass and radius around the respective radius s. അപ്പോൾ ഇവിടെ എടുക്കുന്നത് ആദ്യമേ ഏതാ സർക്കുലർ ഡിസ്ക് ആണ്. സർക്കുലർ ഡിസ്കിന്റെ കേസിൽ we have the center of mass. There's a moment of inertia about the center passing perpendicular to the plane of the disk, which is given by I is equal to m r square divided by 2. This is for the disk. Second one, the given of a circular ring. The moment of inertia about this center perpendicular to the plane. It is given by, this will be ring I r is equal to m r square. So here it is m kd square equal to m r square by 2. Therefore, kd is equal to r by root 2. This is the moment of inertia. This is the radius of gyration of a disk about the axis perpendicular to the plane. Now we have, in this case, we have mkr square. There is a ring mkr square equal to m into r square. So kr is equal to r negative. Kr is equal to r. So what is the relation now? kd by kr is equal to r by root 2 divided by r. That is equal to 1 by root 2. Answer is 1 by root 2. Next, we will see question number 8. Okay. The moment of inertia of a road length L, mass m, about an axis perpendicular to the length of the road and passing through a point equidistant from its midpoint at one end S. So we need to understand what is the moment of inertia for a thin road. So we are considering a thin road like this. The moment of inertia of a thin road about the axis perpendicular to the length and passing through its midpoint is given by I equal to m L square by 12. And if you consider a point to the one end of the road, then if this is the axis, the moment of inertia about that axis is equal to m L square by 3. So I is equal to m L square by 12, I is equal to m L square by 3. M L square by 12 and m L square by 3. Now here the question is to find out the moment of inertia of this road. This is the central axis. We are supposed to find out what is the moment of inertia passing through a point equidistant from its midpoint and one end. This is the axis where we need to find out the moment of inertia. So this is L by 4. The total length is L by 2. So this is the axis I dash. This is ICM. So in this case, we apply parallel axis theorem. Parallel axis theorem. So according to the equation, that is I dash is equal to ICM plus m into L by 4 the whole square. Correct? The moment of inertia passing through its center of mass. This is center of mass plus m into the square of the distance between the two axes. This is L by 4. So I dash is equal to about the center of mass. The equation is ml square by 12. And here you can see that there is one more term ml square by 16. So we'll be getting 7 ml square by 48. So answer is 7 ml square by 48. Question number 9. Two spheres each of mass m and radius r by 2 are connected by massless rod of length 2r as shown. Moment of inertia of the system about an axis passing through the center of one of the sphere and perpendicular to the rod S. So one of the spheres, we'll consider a sphere like this. Another sphere connected by thin rod. Thin massless rod. It's very important to note that it is massless rod. There can be confusions. Always there can be mistakes. So you need to consider the rod is massless. Abhinav, okay. The previous question, right? This one, I dash is equal to ICM is the center, moment of inertia about the center of mass plus m into L by 4 the whole square. So question number 8, I am repeating it once again. So in this question, we are using parallel axis theorem. So here we have the equation for parallel axis theorem, that is ICM is the moment of inertia passing through the center of mass plus m into the separation between the two axes, that is L by 4 the whole square. So ml square by 12 plus ml square by 16. When we consider the LCM as 48, 48 is the LCM. So we'll be getting 4 ml square plus 3 ml square, correct? It is equal to 7 ml square by 48. Understood? I hope it is clear now, right? Okay. Next one. We have just started. passing through the center of one of the sphere and perpendicular to the road. This is the axis where I need to find out the moment of inertia, xy. So for a solid sphere, the moment of inertia about its center passing through the center of mass is given by 2 by 5 mr square. It is 2 by 5 into mr square. So here we consider again parallel axis theorem. We'll consider the moment of inertia passing through this sphere first. Let it be I cm plus the distance plus the moment of inertia of this sphere. So we have three terms coming into action in this. So let this be I xy, which is equal to I cm, that is 2 by 5 mr square for the first sphere. Since there is no mass for this, we don't have to consider this part. Now we move into the second. Now we'll apply the parallel axis theorem. 2 by 5 mr square plus m into the distance between the two sphere is 2r. Distance between the two sphere is 2r. So m into 2r the whole square plus 2 by 5 mr square plus 2 by 5 mr square. 2 by 5 mr square plus m into 2r the whole square plus 2 by 5 mr square. Is it clear? So, sorry, radius is r by 2. So r by 2, it is given as r by 2. So we'll apply r by 2 the whole square, 2 by 5 m into r by 2 the whole square plus m into 2r square. Then again here it is r by 2 the whole square. Both the sphere is having the radius r by 2. Now simplify this, we'll get the expression as 2 by 5 m r square by 4 plus 4 m r square plus 2 by 5 m r square by 4. So I xy is equal to 2 by 5 mr square plus 2 by 5 mr square, which is equal to 1 by 5 mr square, correct? Because it's 2 by 5 mr square by 2, 2 is getting cancelled, we'll be getting 1 by 5 mr square plus 4 mr square plus 4 mr square. That is equal to 5 4s are 20, 21 by 5 mr square, 21 by 5 mr square, 21 by 5 mr square. Okay. Next one. Three identical rods, each of length L and mass m, are joined together to form a letter H. What is the moment of inertia of the system about one of the side of H? About one of the side of H. You're supposed to find out what is the moment of inertia about this axis. This is the axis where you need to find out what is the moment of inertia. So this axis, since it is passing through this road, the moment of inertia of this road about that axis will be equal to 0. And the remaining is of length L. This is of length L. So I is equal to first about this axis it is equal to 0 for the first one. Then for the second one, that is equal to m into L square plus this is the axis where we need to find out the moment of inertia. It will be xy axis, x axis, the y axis, we'll take it as y axis. So I y is equal to about this axis For this rod about this axis, it is equal to ml square by 3. ml square by 3. For this rod about this axis towards one end, it is equal to ml square by 3. Then the distance between the moment of inertia about this axis for this given rod will be equal to 0. Then we apply parallaxis theorem, that is 0 plus this distance m into L square. So we'll be getting Iy is equal to ml square by 3 plus ml square, which is equal to 4 ml square by 3, is equal to 4 ml square by 3. Is it clear? So once again I will repeat it. See this, for the first one, the axis is passing through the first rod itself, there is no moment of inertia. For the second rod, the length is L, the moment of inertia will be about this one end, so it is ml square by 3. For the third rod, we apply the parallaxis theorem because this rod is not about this axis, so we need to find out what is the moment of inertia of this rod about this axis. So we apply parallaxis theorem. About this axis itself, it is equal to 0, then m into L square. That is why ml square by 3 plus ml square, 4 by 3 ml square. Is it clear? I think there is a time constraint is there. So the remaining 5 questions is based on rotation dynamics. You can try that on by yourself. If there is doubt, please concern with us. We'll rectify the doubts. We'll have this. You know that we have doubt clearance sections also. We will rectify the doubts also, right? So the remaining, we have 5 more questions based on rotation dynamics. So today we have discussed about moment of inertia and the center of mass. I hope the sections are clear. So these are typical questions that can be asked for your entrance examination. So please revise this question once again and keep in touch with us. We'll help you from our extent. Thank you. Thank you for the day. Thank you.